A point particle of mass 0.1 kg is executing simple motion of amplitude 0.1 meters. When the particle passes through the mean position, its kinetic energy is 8 times 10 to the power negative 3 joules. Obtain the equation of motion of this particle if the initial phase of oscillation is 45 degrees. Alright, now this is simple harmonic motion. We are going to make an assumption to say the particle is moving vertically. Thus, the general equation that we're going to write will be y equal to a, meaning amplitude, sine, open, angular frequency t plus the phase. Now this is for vertical simple harmonic motion. So that is what we're going to use to simply obtain the equation. Now let us compare the values that we have in the problem. We see if everything is okay. Now from what we can see, the only thing that we don't have is the angular frequency, hence we need to find the angular frequency. Now from the other information that we have that this particle has a mass of 0.1 and it is passing through the mean position. That is, kinetic energy obtained is simply 8 times 10 to the power negative 3 joules. And what we know is that at mean position, that's when you simply have maximum kinetic energy, of which the formula for maximum kinetic energy is simply half the mass multiplied by amplitude squared, angular frequency squared. So from this equation, you can see that what we're looking for is from this same formula, which is angular frequency. Now we're going to substitute our values and see what we can get. Now the reason why this is what you obtain for kinetic energy at mean position and why it is maximum kinetic energy, because for it to be kinetic energy you need velocity, and velocity at mean position, that is 8 times angular frequency. That's to say kinetic energy, which is given as half mv squared, will be, while there's v, will substitute with amplitude times angular frequency. Thus kinetic energy will be equals to half mass, in brackets we say a times angular frequency. Thus we get half mass amplitude squared angular frequency squared. Okay, that's how we get to have kinetic energy. All right, now I'm going to wrap this part, and now I'll start substituting the values that are given in the question. Kinetic energy is given as 8 times 10 to the power negative 3 joules, which is equal to half times the mass, which is 0.1, and the amplitude is 0.1 squared, 10 times angular frequency squared. So now let's work this out. Left hand side maintained, then we get half. So 0.1 times 0.1 squared simply gives us 1 times 10 to the power negative 3 multiplied by angular frequency squared, not forgetting that we are dividing by 2. Okay, so left hand side maintained, then on the right we simply get 5 times 10 to the power negative 4 upon calculating, multiplied by angular frequency squared. So we divide both sides by 5 times 10 to the power negative 4 so that we obtain the angular frequency. Upon doing that, we get that angular frequency is nothing but 16. And to get angular frequency, we square root both sides. Thus we'll have angular frequency to be equal to 4 radians per second. Now we have the missing item, and we're going to so I'm going to rewrite the equation, which is a sine angular frequency t plus the initial phase. So upon substituting, get 0.1 for amplitude, then sine, while there is angular frequency, we'll put 4, then we have t plus the phase is 45. So this is the answer or the solution to our problem. Thank you very much for watching this.